Hello guys, welcome to my channel Let Us Code. Today I came up with a new video series on Apache Spark. So let's explore Spark step by step in this video series. I hope you like this tutorial. So let's start with the Spark tutorial series part 1. Just make sure that even you are familiar with the Spark, I suggest you to go through this video till the end. In this short video, I will talk about the basic definition of a Spark or introduction of a Spark along with its origin, point and current version. So guys, let's start. In our next slide, we'll talk about the Spark introduction. Okay, so before we understand what is Spark and define this, let's first read what experts say about it and how define this. So below are definitions from Apache websites. It's an official definition and Wikipedia page. I took these two just for a simplification. So guys, let's what actually Spark says about this. Like Apache Spark is a unified analytics engine. Okay, now analytics is something which is very important because most of the time people think that Spark is a programming language or it might be some kind of a new data processing tool or something like that, but actually it is moreover towards the analytics. Okay, and that's what the official Apache Spark page says. So it's a analytics engine. Now another stuff is a large scale data processing. Now you can use Spark Apache Spark for a like kind of processing of one file, text file, JSON file, which is like it might be of KBs, MBs, but you will get a you can leverage its benefit when you work on the large scale data set or a big data basically. Okay, so that's what the Apache says about it. Now what Wikipedia says, okay, Apache Spark is a open source distributed general purpose cluster computing framework. So guys, there are two things. One is the open source. That's what, okay, that's what's become so popular because it's available to all. Okay, and the next thing is cluster computing framework. Guys, like what I said earlier, it is not about a language or any specific technology, but it is a cluster computing framework, guys. So make sure this is the important thing. One is the analytics engine, then second is the cluster computing framework. So you can make a note of it. Okay, so these are two things which is specific to Apache Spark. Now before we explain more about Apache, let's go back with some history. Okay, like how Apache come into the picture and what is the need of the Apache Spark. And this story began with the Google. Okay, so just a little bit history about this big data computing framework that we start from a need raised by Google itself. So guys, after internet comes to market, at that time data is expanding exponentially. Okay, so before internet, like we have to maintain some record file that can be manageable, but when we talk about internet, a lot of blogs come into picture. People are sharing a lot of audio, video, media files that is huge in volume. Okay, and to manage that, uh, we need a technology to process something better. So Google was working on that. Neither traditional storage systems such as RDBMS or old traditional ways of programming were able to handle the scale at which data can be processed. So same thing, Google is struggling and wanted to build the system to enhance the internet's index document. Okay, so when Google analyzed it, Google addressed this issue, and first they came up with a solution. Okay, and the solution is in a three format. One is a GFS, second is a MR, and third is a big table. Now guys, this is a proprietary work of Google. Okay, so they didn't expose much of the details, but yeah, they published 3 papers each for them, and these papers has been studied and analyzed by various technological groups. Okay, and they read about it, they analyze it, and they work on that whether they can use it by their own. Okay guys, so let's talk about the GFS first. Now what is GFS? So the full form of GFS is like Google File System. So is it a like simple file system? We have already worked on many file system, like Windows have a file system, Linux have file system. Every operating system is coming with some file system to explore the file, store the file, read the file, and delete the file. So we can perform all the operations regarding the file for using a file system only. In similar way, Google come up with the file system. Now this file system is not an ordinary file system. This file system is a distributed file system. Okay, that file system is capable of you know to be installed on cluster model. Okay, so this is the first thing, GFS. And there are some key terms for that. One is the fault tolerant regarding GFS, then second is a DFS, distributed file system, and it's a cluster form, and the last is a commodity hardware, guys. So these are the I will repeat one more time: fault tolerance, DFS, cluster form, and commodity hardware. So these are the four pillars based on that GFS come into the market. Now about the big table. So why Google introduced a big table? Because that's a scalable storage of structured data across GFS. It's a scalable storage. It is not about the file system. It is about the how you are going to store the those big data or huge volume of data on the GFS. So they come up with the big table. Now they need a computation mechanism. Okay, like there should be some process by which we read the data, we process the data. For that they come with some programming model. That's programming paradigm. It's based on the it's a MR basically, and they call it as a map reduce. M stand for map and R stand for reduce. So for guys who are already belong from big data platform, big data background, they must aware about the MR. But for those who are new to that, you can just explore with some other resources, because this video is about Spark only. So guys, so that's what, like, Google introduced and Google addressed the issue, but the story will just a beginning of the new innovation which going to be come into the market of big data. Okay, now guys, when we talk about the map reduce, okay, so Google somehow resolved the issue by introducing those three features. But later on, when it come into the market, okay, so it's been implemented by the various Hadoop platform, we get to know that map reduce is having some issue, like regarding performance, programming model, and configuration automation. Now what developers are constantly saying that regarding the performance of map reduce, it's initialization, scheduling, coordination, data manipulation, and intensive disk input output operation. So guys, this is important. It's an intensive disk input output operation. What does it mean? That for every operation, it will it will not work on the in-memory data, in-memory process. It's like a moreover a input output operation for a disk, right? And you know that for every operation that's performed on disk is quite expensive for the processing. So that is the main reason, when people like developers question this MR. Second is a programming model. It is a single input operator, okay, which it's like deficiency. The developers consider this a deficiency. Second is a fixed processing pipeline, okay, it's a job chaining. And then there is no support of iterations. Guys, iteration is very important. So whenever you work with any programming model, iteration is something, it we consider as a very important thing. There is no support for iteration in this map reduce. And then there's a regarding, they feel some issue with the configuration as well, like the all the parameters are very sensitive, okay, and it's quite a complicated for a new learner, even for a new project itself. Like, it's hard to set up the MR jobs. Okay, so people are constantly working to improve the MR. Now the step has been taken in the next time, okay, by a UC Barclays, okay, who had previously now UC Berkeley who previously worked on the Hadoop MapReduce took challenge and acknowledged that MR was inefficient or intractable for interactive or iterative computing jobs and a complex framework to learn. Okay guys, so let me show you like the history of Spark itself. So it started at the UC Berkeley AMP lab by the Mathia Zaharia, okay, in 2009 at AMP lab. So the foundation of the Spark is laid down by Mathia Zaharia in 2009 by the UC Berkeley AMP lab, okay. Later on it comes to 2010 open source under a BSD license, and then in 2013 it is being hand over to Apache Software Foundation. The project was given to the Apache Software Foundation. The license was changed to Apache 2.0, and the people who developed this and donated this to Apache has set up their own company known as a Databricks, and Databricks will keep on working on the in a form of open source. So it is owned by the Apache, it is owned by the Apache Foundation, but the work and implementation has been done by the Databricks team. So Databricks team is, so who these are? They are nothing. These are people, who have designed and developed the Apache Spark. So become an Apache top level project used by Databricks to set a world record in large scale sorting in November 2014 itself. And when this record was set and people get to know that it's much faster than our traditional Hadoop job, MR job, it's become very popular. Now it exists as a next generation real-time and batch processing framework. Guys, again there are two things. One is a real-time and batch processing framework. So it is like come with the streaming as well. This is mainly talk about the stream. Okay, and this is one of the feature of Spark which we're going to discuss in later tutorial. Now let's go first and check what on all the what is the latest version of Spark. So you can simply go to the Google, okay, and say okay, so here we'll talk about the Spark latest version, and when I click on the Spark latest version, I can see Spark 3.0.1 is the latest downloaded version. But guys, industry is not, not many people are using this. We are still with the Spark 2.0 version. So what's the difference between various versions, how Spark, how to implement the Spark, how to set up a Spark? Please subscribe to my channel, stay tuned with me. I'm gonna upload few more videos in a detailed way, how to set up a Spark job, how to do a programming, and what are the features of the Spark itself. Thank you guys, thank you for your support, thank you for listening. Take care.